Hey everybody, this is Doc Sheep. We're going to go ahead and start a new series of math, and we're going to go ahead and talk about differential equations in this series, specifically on ordinary differential equations. And this is a class that I've taught many a time, both as a grad student and as a professor. And this is one of my favorite classes to teach because of how much the math actually complements reality. Like there's a lot of physical application. So those questions about what am I ever going to use this for usually start getting answered in classes like this. So what I'd like to do is actually present exactly what I would during a semester or at the very least a quarter-long course in differential equations that you would see in a university setting. So let me make sure that we're clear about the prerequisites that you need for this particular set of videos. Yeah, you really can't talk about differential equations unless you know some calculus, and specifically you need to be able to get through some Calc 2 in most places. So this would be integral calculus. So you need to be able to integrate things, right? That makes sense to us in order to talk about differential equations, which are equations with derivatives in them. You need to be able to undo derivatives, and that's exactly what integrals do. And in this class, the way I present it in particular, or the way that the textbook that I supplement is presented, you will also probably benefit a fair bit from knowing some vector field calculus, and very, very little vectored field calculus, just to understand what these objects are and that there are parameterized curves that flow through them. That would be probably the extent to which we will need some multivariable calculus in this series. Let's see. You will also benefit greatly from some linear algebra, and ideally you would talk about eigenvalues and eigenvectors, since we will be talking about systems of linear differential equations. We should probably talk a little bit about these as the series progresses. So I will supplement a little bit of linear algebra along the way here, but I do assume some integral calculus. I don't teach it along the way, since it is a prerequisite for most differential equations classes. And in some institutions, linear algebra is actually a prerequisite for this class, and actually in a fair bit of universities, they actually are co-requisites of one another. In fact, some places even offer linear algebra and differential equations in the same class, in something that some places would call linear analysis, perhaps, or maybe calculus for engineers, or differential equations for engineers, something to that effect. And it's not entirely necessary, but it does help your intuition a fair bit to have some form of science, technology, and engineering classes to give you some physical intuition behind why we are studying these mathematical objects in the first place. You'll even see on the cover here, right? These are my own notes that I've typed up. They're all nice and pretty. I'm really happy with them. Although there are a few typos from time to time, and I will go ahead and point out where those are as we flip through the notes. But your prerequisites from other STEM classes, once you get to this point in university, you're probably going to have some physics under your belt, maybe a Gen Chem, maybe some biology. And these are all really great STEM classes to help motivate why we're studying differential equations in the first place. Awesome. So those are what I'm going to be expecting, or what I'm going to be assuming that you have knowledge of as you're going through the lecture series here. So apart from the cover page, oh shoot, I'm drawing on it. No, I shouldn't be drawing on it. No. And we go back. There we go. Now I can just slide through this. There we go. Right, just to give you a brief overview of what I'm going to be talking about in the lecture series, this does actually follow a very popular textbook. I'm going to not state who the textbook is, but I'm pretty sure if you are in a popular university, a very large university, odds are you have this textbook, or that it is one of the recommended texts for such a class. And I'm following the structure of those sections very closely, and in fact they do line up exactly with the 10th edition of this textbook. So I'm not going to be advertising the text, but I'm pretty sure you could figure it out with enough research here. I believe the titles of the sections actually do line up as well. But I'm going to be following these guys in the order first, second, third. We'll skip chapter 5, and I haven't decided if we'll do chapter 6 and 7 in this particular order, but I imagine it's probably not too much of a problem if you go to chapter 7 before chapter 6, but it really doesn't matter too much. But at the very least, we know that we are definitely saving series solutions for last, and I think that's going to come down to whether or not you all want that section to be created. So let me know if in the comments if you want chapter 5 where we talk about series solutions for differential equations. So this is the order that I'll present, and again, just to remind you, this is exactly how I would present it in a university level class. Usually second, possibly third year. Very, very few cases you'll actually do this in your first year as a math major, but odds are it's usually a second or third year course where you would be taking this. But I will present it exactly as I would in university.